In this topic, we are going to have a discussion on polar coordinates because coordinates can be given in a polar form like this. R is the distance from the origin to where that particular point, because a position of a point P in a plane may be given in terms of distance from the fixed point and the angle it makes with the fixed point. So the distance from the fixed point is this. This is the distance we're talking about, r, and the angle it makes in the anti-clockwise direction is actually theta. So polar coordinates are given in that form, where r is the distance from this point to where that point P that we are talking about is, and the angle is the angle this point makes with the fixed line, which is the x-axis. So is the angle along that particular point. So from this one, using SOHCAHTOA, we can be able to see that this side is opposite, this side is adjacent. So in terms of r, x is equals to r cos theta. In terms of r and theta, y equals to r sin theta. So this is what we have tried to identify at this given point. And from here, we can be able to see that tan theta is equivalent to opposite over adjacent, which is tan theta is opposite of adjacent, which is actually y over x. So polar coordinates are given in this format, the way we have tried to identify here. And the other thing that you need to remember, that Cartesian coordinates are given by xy. So that has to be well understood with you, so that whenever you are going to do this topic, you know exactly how to write those coordinates. And if you are new to Proflan YouTube channel, consider subscribing so that anytime I'm going to upload further tutorials, you'll be notified. We are going to have a series of polar coordinates from the beginning to the end. So this is the first introductory part, which is going to form a basis of what exactly we're going to do in this particular topic. So the first area that I want us to work out here, we need to go straight to the example, and we're going to have the first set of our examples, whereby we're told to find the Cartesian equation of each of the following question. So find the Cartesian equation of each of the following. So which means that we are going to be given the polar equation, and then you are supposed to convert it to the Cartesian equation. So the first equation that we are going to have at hand here, the equation says you are given r equals to 4. Now this is the polar form of the equation. So if you can look at whatever we have here, yeah, we know that actually our r, we did not identify it. We need to identify what r is, and just identify here. For you to find r, our r is going to be square root of x squared plus y squared. This is how we find r. So if you are told r equals to 4, whereby this is actually a polar equation, in order to convert it to the Cartesian equation, what you will do here is to r is actually that. So we can say this is r, but our r we know is x squared plus y squared equals to 4. So meaning that we are going to square both sides, and this is going to end up being x squared plus y squared equals to 16. So this is the Cartesian equation of this format. So basically, we are going to do this kind of conversion. Now let us look at the second example. The second example, you are given r cos theta. R cos theta now is equivalent to r cos theta is equivalent to 3. So All right, because we want to convert, we need to convert now r cos theta equals to 3 to a Cartesian equation. Just look at this. We have x here. R cos theta is x. So meaning this equation now becomes x is equals to 3. That is the Cartesian equation. And we are done with that. So that's straightforward. It's just that straightforward. So let us change the gear and look at this equation we are given here. The equation says r equals to, just check here. The equation says r equals to a, part C, r equals to a into bracket 1 plus cos theta. So this is what we are given. R equals to a plus into r equals to a into a. We are given here r equals to a into 1 plus cos theta. So at this point, we are going to make use again of this equation here. So r is actually square root of x squared plus y squared equals to a into bracket 1 plus. But if you can look at cos theta, we are going to get it from this point here. So cos theta is going to be r over x. So cos theta is going to be r, actually is going. Now from this equation here, you can see we can actually have our equation as cos theta can be written as x over r. So can equally say here this is actually x over r at this given point. So which means that we can now decide and square both sides here. We can be able to square both sides. And if you square that, what are you going to get in that case? If you decide to square that, what do you get? Right? So, and you cannot proceed until, yeah, let me just show you. We can now say again that this can be written as square root of x squared plus y squared equals to a plus ax over root x squared plus y squared, because we know what actually r is. And the next thing that I'm going to do, I'm going to multiply all through by the square root and its content all through x squared plus y squared equals to a root x squared plus y squared. Yeah. So once we have this, and then we're going to remain with ax like that. So meaning that this equation now is actually the Cartesian form of our equation that we were given, which is a polar equation. So this polar equation has a Cartesian form, which is like this. Okay. All right, let's move to the next example here, whereby that we are given d, and d is given as 2 over r equals to 1 plus cos theta. 1 plus cos theta. So meaning that this part over r, we are going to say 2 over root x squared plus y squared equals to 1 plus cos theta can be written as actually x over r, which means that this can be written as 2 over root x squared plus y squared equals to 1 plus x, and our r is x squared plus y squared. So which means that in the process of working out this question, we are going to ensure that we are trying to rearrange this. if I multiply all through by this value here, I multiply all through by root x squared plus y squared, multiply by root x squared plus y squared, multiply by here times root x squared plus y squared. So if I multiply that way, this one will cancel out, this one will cancel out. So I'm going to remain with this part here that 2 is equivalent to root x squared plus y squared plus actually x. So if I decide here, I can be able to rearrange these equations that I have, and so that I can be able to expand and I have a bit cleaner equation. So I can be able to say root x squared plus y squared is equals to 2 minus x. So meaning that this part can be squared. So meaning we can be able to square both sides. We square this part here. Also this is squared. So if you square that, you are going to remain with x squared plus y squared is equals to what? So that if you expand this, we are going to have 4 minus, actually we are going to have 4 minus 4x then plus x squared in that case. So you can see now this part and this part is going to cancel. So at the end of the day, we are going to have y squared is equals to 4 minus 4x as our Cartesian form of this particular equation. So in the process of converting a polar equation to Cartesian equation, you need to understand those basics: what x is, what y is, what is tan theta equivalent to, and what r is expressed in terms of actually x and y. Area, we are going to say find the polar equation of the following Cartesian equations. So this is actually part 2. Find the polar equation of the, and we are supposed to convert this to a polar equation. Something that we need to remember: x is actually r cos theta, but we have to square that, plus y is actually r sine theta, so we have to square it because it's squared here, and then we say is equivalent to 9. Then which means that this is going to be r squared cos squared theta plus r squared sine squared theta equals to 9. So after having that, we are going to factor r out. We shall have r factored out. We shall remain with cos squared theta plus sine squared theta is equals to 9. But you need to remember that cos squared theta plus sine squared theta from trigonometry is equals to 1. So this part is going to enable us say that therefore our r is equals to 9. So this is the polar form of this particular equation. So this is going to enable us remain with r squared is equals to 9. In order to find the final answer, we are going to find square root. Square root, this implies that r is equals to 3. And we know that radius r has to be positive. So we're going to say now this is our final answer. This is the polar form of that equation. Now, what if you have another equation, xy is equals to 16? How are you going to work this out? Xy equals to 16. So something that you need really to remember at this point is that what is x and what is y. So meaning this cos theta times r sin theta is equals to 16. That's the first thing that we really need to do. And this is going to remain with us r squared cos theta sin theta equals to 16. In double angle formula, remember that sine 2 theta is actually 2 sine theta cos theta. So this formula here is going to enable us reduce this equation that we are having here. So meaning that we are going to say this can be written as because we are having this 2 sine theta cos theta here, we can therefore say that this is sine theta cos theta is equals to 1 over 2 sine 2 theta. We have all the rights to say that. So meaning, so therefore, this equation now can be written as, from this point, we're going to say r squared over 2 sine 2 theta is actually equivalent to 16. We can be able to say it can be expressed in that format. Then we can multiply by 2 both sides, and we end up remaining with r squared sine 2 theta is equal to 32. Now, this now becomes the stuff that we wanted. This becomes the final answer. This is the polar form of this equation, which is a Cartesian form. In Cartesian form, now it can be converted to polar form to be like this. So the concept of double angle formula was of great help for us to proceed from this particular point. This is C, x squared over 9 plus y squared over 16 is equals to 1. This is the Cartesian equation. Now, how do we convert that to polar form? Remember, the first thing that we are going to do at this given point is to ensure that we are going to express x and y in terms of r and cos and sine. So which means that this is going to be r cos theta squared over 9 plus r sine theta squared over 16 is equals to 1. And finally, this is going to reduce to r squared cos squared theta over actually 9 plus r squared sine squared theta over 16 is equals to 1. So if you can look at this question, the way we are having it, there's nothing much we can be able to do. There's no way we are going to simplify this question any further. So we are going to save our energy for more other questions. So meaning that this question that we have here, we are going to leave it in peace the way it is. So let's transfer that energy to part D, and polar equations. It means we are going to move to the next area, and the next area is drawing these curves of polar form. So here we know that x is actually r cos theta squared plus r sine theta squared plus is actually plus 8 r sine theta equals to 16 at that given point, equals to 16. So once we have this, we're going to try to work out this. This is going to be r squared cos squared theta plus r squared sine squared theta plus 8r sine theta equals to 16. So we are going to factor r out in the first question, r squared out. We are going to have cos squared theta plus sine squared theta plus 8r sine theta equals to 16. So we know that this part here will go to 1. So we end up having our equation reducing to r squared plus 8r sine theta equals to 16. And actually this becomes now our polar equation. We are going to leave our answer in that form, that r squared plus 8r sine theta equals to 16. All right. So in the process of converting this to polar form, we know what x is in polar form. X is actually r cos theta, but since it's squared, we are going to square this, plus y is usually r sine theta. So since it's squared, we are going to square that y. And this now, the entire of that is squared, then is equals to x squared here is actually r cos theta squared minus r sine theta, and that is squared. So that if we square this, we are going to have r squared cos squared theta plus r squared sine squared theta, that is squared, is equals to this is r squared cos squared theta minus r squared sine squared theta. So having this, we are going to say now we can factor in inside the bracket, we can be able to factor r squared out. We remain with cos squared theta plus sine squared theta, and then everything there is squared is equals to, here can we factor anything out? We can say r squared into cos squared theta minus sine squared theta. So that we can now say, if actually this one is going to reduce to 1, so we end up having r squared then squared is equals to r squared into cos squared theta minus sine squared theta. So you can see now this r squared and one of this r squared is going to cancel out, because at that given point we can say if you divide by r squared to r squared, we are going to try to make things cancel out, and we are going to have r squared equals to cos squared theta minus sine squared theta. So what does this represent in trigonometry? What does this part represent in trigonometry? So we know that that represents r squared equals to cos 2 theta. That's what we are going to have in this case. Yeah. So meaning that this form that we have now is the polar form of this Cartesian equation. So basically, that's what we are supposed to do. So the next episode that we are going to check and check in the description below is sketching of polar curves. Yeah, check that in the description of this video on how you go about it.